Hello, my name is Christopher Baugh, president of NSR, and I'm pleased to moderate this important PTC session entitled Cloud Computing via Satellite. Now, we know the satellite market's in a state of transition, whether it's new constellations that are highly visible, launch successes, database products, and really so much in terms of innovation. It's pretty safe to say that the satellite industry today is very, very different from what you would have known 5 or 10 years ago. One application specifically we're focusing on today that is driving a lot of this innovation is the cloud and its crossover to the satellite market. We've done some research here at NSR to show that about 52 exabytes of traffic will be flowing over the satellite-enabled cloud within the next decade, approximately 10 to 11 billion in cumulative revenue, which is pretty enormous by satellite standards. Suffice it to say, it's a big growth area, driven by the largest IT and telecom players that are entering the satellite world. Because of that, we're blessed to have one such speaker and player today, which is Microsoft and Mr. Yves Pitsch, who is the principal program manager from Azure Networking at Microsoft. So Yves, thank you for joining us. Pleasure to have you. First question is really, cloud computing in space. Walking us through Microsoft's, your position, your platform with Azure in the satellite world, and really the big question, why now?
Yeah. Hi, Chris. So the starting point is, if you look at our global network, we run one of the largest global network in the world, with over 160,000 miles of subsea, terrestrial, and metro optical fiber to connect people all around the world. These customers, they build and consume services such as Office 365 and Azure, right? However, many of these customers, they also operate in remote, rugged environments and have an increased need for access to data and bandwidth to consume these cloud services. Think about, oil rig, mining, where they need to run some IoT services or machine learning type of models and so on. So back in September, we introduced Azure Space. Azure Space, with Azure Space, we have the ambition to make space connectivity and compute increasingly attainable across industries such as agriculture, energy, telecommunications, and governments. And we believe that if we combine resilient satellite communications with the Azure's ability to provide high-performance computing, machine learning, and data analytics, we open the door to tons of new opportunities for both public and private sector organizations.
So really, this is about extending the reach of the cloud, would you say? This is about getting to those new use cases, those remote users who may be outside the traditional terrestrial network. This is about just expanded access to the cloud.
Absolutely. We stretch our network to be as close as possible to the end customer. Now, sometimes the last mile is longer than usual, and that's what we are trying to address, is make sure that you get access to the cloud wherever you are. Yes.
Okay, very good. Now, you mentioned a number of user groups, agriculture, mining, others. Who are the most needy in terms of need access to the cloud? Who are the user types? I'm really focusing in on the Pacific as well, because this is where our user base is here. Who needs it most, do you believe?
So the Pacific scenario is, of course, if I look at the top scenarios, I think you introduced the first sentence, you said you talk about exabytes of data, right? And that's exactly what's happening now. So on the Pacific, think about connected cruise, where passengers, they need to access to the internet, just basic internet access. The crews on the ship, they need to access to enterprise applications, right? They need to access to Office, right? So that's kind of one market. But then, of course, internet access in remote areas is key here. Think about tons of new scenarios like in-flight entertainment. In agriculture, of course, if you see the way this is evolving, this sector is very connected, right? It's not about just managing fields. It's about connecting that with sensors, using drones, using images from satellites and whatnot. So we see tons of data transiting over satellite communication, and that data needs to be processed somewhere. Now that you are talking about exabytes of data, this is where the cloud makes sense because we have that elasticity on scale. Yeah.
Okay, excellent, excellent. Now, coming back to the satellite angle, which is something I'm quite keen to understand, we've seen an announcement or two with you in this space. So it looks as if you have a collaborative type of approach when it comes to this space. So lots of partnerships, lots of distribution, maybe partnering, peering arrangements. What can you walk us through what those look like, and who your partners are and what those look like in terms of who's doing what, I guess, in the system?
So we announced a couple of things back in September, right? We announced Azure Space, which is all about connectivity, the way I explained. So we partner with the leaders in space, in the space community to extend the Azure capabilities, right, with satellite connectivity. So partners like ACS or Starlink, we announced our mobile data center solutions, which is all about providing satellite connectivity on top of a container type of scenario for compute, right? We also announced a product which is part of the overall connectivity strategy for Azure Space called Azure Orbital. And in that product is targeted for satellite operators, really, in the sense that we provide a ground segment for satellite operators, and we allow them to kind of access to their spacecraft on downlink information straight to the cloud. That's what Azure Orbital is doing. It's really a partner play in the sense that if you are satellite operators, you need a bunch of ground stations. You can connect to a Microsoft ground stations. That's more like the Earth observation type of scenario. You can connect to existing ground stations and leverage our global network for routing. And that's the communication scenarios. So basically, we interconnect a network of ground stations together, and we work with our partners to kind of transform that ground station into a digital platform. And that's what we are doing. At the end, we are a partner. We are just a platform. We connect, or we build an ecosystem of partners so that you, as a satellite providers, you can compose new services, leveraging marketplace services.
Okay. And at what stage are you now? Are you in the public, the commercial phase, or what does the roadmap look like for orbital or space? What does it look like right now?
Azure Orbital is in private preview now, and looking to switch to public preview next year. Today we can onboard customers. The platform is ready to go. I think between now and public preview, we'll extend the footprint of our infrastructure and the range of partners who have onboarded to the platform. So if you look at the partners today, we have software modems. Think about Kratos and Emergent. We have teleport partners like KSAT. We have mission control partners like Cubos and whatnot. So that ecosystem is coming together into the platform, and we'll keep working with our partners to kind of enrich that platform on ecosystem.
Okay. Now, practically speaking, if I'm a customer and I want access to this platform via in space, walk me through kind of the nuancing of that. Especially, maybe I've invested in existing teleport infrastructure. Maybe I've invested in something. How do I gain access to this network? How do I gain access? Is this just going through my service provider in the satellite world? Do I work with you? How does that look and feel in terms of customer relationship?
So two types of customers. You have the enterprise customer who needs to access to the cloud over satellite communication. In that case, what we do, since we have interconnected the ground stations together, we have a direct access to the cloud. Having said that, the customer will interact straight with the satellite partner to get access to the cloud. So we do not sell satellite capacity, as part of the platform today. Now we have the other type of customer, which is a satellite operator, right? That in that case, or the telco. In that case, what we provide to them is a platform to transform the ground station into a digital platform. So we basically consider a ground station as an antenna, a digitizer, and then we transport RF over IP to the cloud. We process it or demodulate in the cloud through software modems. We support up to 500 megahertz wideband, and then we service chain all the services to kind of allow routing all over the places. So that's a different category of customers for us. But to your point, enterprise customers will interact straight with our partners to get access or the best access to Azure.
Okay, interesting. Now you've had some I guess experience early days with some trial customers and some beta maybe at this stage. Early days experiences you've gained, things maybe you know now that you didn't as it relates to satellite connectivity. Are there specific nuances of this telecom distribution model that you really maybe didn't think of up front, or you're learning as you're going? What is it unique about the satellite world?
So I think what's interesting is like each mission is unique. So there's no like one scenario fit all type of things. And that's the challenge. And this is why we need to build a platform that is as generic as possible, right? We need to have an ecosystem where we can bring things together without forcing anything, because we require customizations, we require standardization. And as you know, standardization is still an area of improvements in the space industry, right? And the uniqueness of the mission is something we have to handle. And this is why we look at being a platform, not a product, in the sense that, all packaged. We believe in more like integration with our partners to build the best solutions, end-to-end solution for the customers.
It's interesting, the satellite world, you're right, standards and satellite don't really go hand in hand, minus the RF link and DVB and some of the common broadcast standards, which is a big player like you, which likes to drive volume. Of course, it's a volume game. That's an interesting observation where everything is a bit different. Everything comes off a bit siloed, right? And standards would make everyone's life easier, but it doesn't seem like, is that a requisite for you to get to that point, or does this just have to be, you have to work a little bit uniquely in each of your players and partners?
So multiple layers. So this, what I said is like, if you take an antenna and if you transport the RF over IP, we kind of force a format. We have embraced Vita49, and that's what we require our software modems to embrace as well. So that's a starting point, but it's just a small piece of the puzzles, right? We have to look at how we do network automation, how we embrace standards like ONAP and other things, right? There's lots of standards around us. So today we're not forcing, we're still learning, but for sure there are already some pieces of the chain that we mandate, like Vita49 is one of the format we are looking after. Okay. After that, I think the market will also tell us, right? We are not trying to constrain our product to a specific set of standards today.
Okay. One aspect of that is, thinking about security and resilience in the network. And one aspect of satellite remaining off the grid, so to speak, and being its own siloed network is it's secure, or it's more secure than you would argue in some ways, especially for military customers, others who have protected waveforms and other aspects. Is this a pushback in our world? When you start to put traffic into the cloud, in the satellite world I'm speaking of, is this just an education process with users to get them to understand that it can be secure, it can be resilient? Or, what knowledge, what comfort level do they have, the user base in the satellite world mainly?
I think we're over that discussion. We used to have that type of discussion many years ago. I think it's understood that when you move, assets to the cloud, whether we have this concept of virtual network, which is basically your own boundary in the cloud. These are like highly compliant networks, highly secure, that can be in commercial clouds or gov clouds, by the way. And by moving some of the functions to the cloud, in fact, you become much more secure, right? Because you are in these kind of secure boundaries, but you also give control to the customer, right? Mm-hmm. But it's a balance, right? At the end, some of the functions will run locally, some of them will run in the cloud, but we believe that on the way we have developed Azure Orbital is to make sure that you can run everything into the cloud, and even just transport raw IQ data from the ground station to anywhere in the cloud, and allow the customers to process it on decrypt it the way they want. So I believe that it's well understood today in that industry, and the concept of security is of course key, and in fact that will trigger the adoption of services like Azure Orbital.
Okay, then a couple more questions as we're getting near the latter part of the session here. It's any question or any new technology, or service platform, it's all about making money, saving money, or increasing efficiency. Three real key metrics that we always as analysts look at in this world. So example of each of those: making money, saving money, increasing efficiency. Could you give some kind of take an example of a use case maybe that you could point to?
Yeah, making money. Okay, let's look at that part. So I'll give you a scenario. You can see today in the satellite industry that there's lots of verticalization, right? So many partners are moving away from selling megahertz to selling solutions, edge compute, IoT, SD-WAN type of scenarios and whatnot. And sometimes they sell a blend of services, 5G and satcom and whatnot. So by moving the satellite transport into the cloud, you can compose new services. Now you can add machine learning on top of that. You can add AI, you can add data analytics. So you can enrich your service and sell value-added services to your end customer. So now the discussion is shifting from selling capacity to selling end-to-end solutions. And that's where the cloud is coming. And we see that trend in verticalization, in about selling, end-to-end solutions. And I think it's really a revenue. It opens the door to a bunch of new revenue scenarios, and that's one aspect. The cost reduction is important as well. When you consume cloud services, first it's a pay-as-you-go type of model, right? It's not a perpetual license. So you deploy assets, or services to the cloud. You activate them when you need them, and you pay only for what you use. That's one aspect. So this is why the more we can digitize the ground station, move assets to the cloud, the more you get these benefits of pay as you go. But you also shift kind of investments from capex to opex. So it's not a must, but many partners are looking to do this shift of investments from capex to opex type of scenario. And so I forgot your last topic.
Oh, the efficiency. I gave you a lot of homework. So,
so the efficiency is the same thing. So when you move functions to the cloud, you're moving away from monolithic applications, right? You can have one big application running in the ground station, or you can distribute that into the cloud. And now you can scale each function individually, right? So when you improve your scenarios, improve your applications into the cloud, now you can benefit from what we call DevOps. So DevOps is kind of the classic discussions we have around life cycle of the applications. How can we, upgrade one services without impacting the others and whatnot? How can we manage the life cycle of these applications? And that's what the cloud is bringing. These operational efficiencies, being able to spin services when you need at the best cost.
Yeah, I mean, if your first point on making money and you being not just being a megahertz provider is so important, because the satellite world today is the increasing glut of capacity operators rethinking their businesses, and you can't just be a generalist anymore. You really can't. You have to offer platform solution services, maybe vertically or otherwise, and really specialize. Now, the second point on capex to opex is kind of the next question I have. They're shifting from expensive assets, big uplinks, doing everything yourselves, to basically allowing others to do it for you and focusing on the services, focusing on value add. The theme of network virtualization, and I know one of your partners, Kratos, there were some announcements that were made around some part of that aspect. You mentioned their name earlier. Is that what this is going to look for in the future? So if you want to access satellite anymore, you may or may, it's just a software. I mean, yes, you need a modem and an antenna, everything, but it seems as if the road's leading to complete virtualization in the world. If you look at the long-term roadmaps and you having partners in that world, would you agree?
Yeah, that's what we believe in, and this is why if you look at Azure Orbital, we built this marketplace platform where you can pick the functions or the network functions you want. You want to pick demodulation, mission control, image calibration, data processing pipeline, and whatnot. The value of virtualization is that you can decide where you want to deploy your code. So once it's virtualized or defined in the form of container type of applications, you can say, I run this code in the cloud, like unlimited compute, storage, and whatnot. But you can also decide to deploy that into the edge compute type of scenarios. Now it's the same code base. You just define where you want to run this code. Now you get this type of flexibility, right? If it's that's what you get out of container/virtualization. You get this flexibility to run with your code in the cloud, like the big ones, or at the edge of our network, the Microsoft network, or at the edge of your network. We have tons of form factors for the edge. Think about Azure Stack Edge and whatnot, where you can just get on a device or an appliance, from the Azure portal, get it to your place, and then deploy your assets into your Azure Stack Edge solution. That's what you get with virtualization.
Okay. Yeah, fascinating. The use cases and just the entire deployment, it's a complete mind shift from where we've been in the satellite world to get to that, because we always in our heads think, I need a box, I need a physical location, I need a line card, I need all of this that goes into it. And it's, if you think about where this is headed, this is much different and bigger, frankly, I'd say.
Yeah, I mean, you may have few challenges. You have physics, right? I think space industry is driven by physics. So obviously, transporting RF over IP means you have big pipes, right? So if you want to process your ground station signal into the cloud, instead of having small fiber, pipes, you need big ones. 500 megahertz signal is about 20-25 Gbps of traffic, right? So there's a line you need to define, and this is why the edge compute can help you define that line. Like, how much do you want to run locally? Do you want to run locally? How much do you want to run in the cloud?
Indeed, absolutely, and that flexibility in terms of configuration on the fly, I mean, it makes a lot of sense. I mean, but again, maybe one of my last questions is, okay, thinking about the satellite world, and you've had some time in this world, is this, or does the industry get it yet? I mean, is this industry on board? I mean, they understand the language you're speaking? As I don't want to say it's not a push or pull thing, but at what stage is the industry in acceptance? This is a thing. This is happening now, and it's starting to take shape. What stage is that industry in?
I think we are lucky to be in a very dynamic market right now. Lots of things happening, in the space, on the ground, 5G as well, because at the end, these two worlds are kind of connected to some extent. And it's a very dynamic market, and there's a need to go fast. There's a need to, the fast aspect is important, right? How can you quickly launch a new communication system in the space or new type of scenarios in the space without having to build a massive ground segment network, right? And this is where we can help. And I think it's understood, and you can see the trend where you can see now teleport locations being deployed close to data centers or being deployed close to fiber. So because it's a way to kind of leverage the best of the two worlds, the cloud and the space. On that trend, you can see it's coming. And so I think it's a matter of time, but it's understood that the space industry and the cloud industry, if you take the best of the two, you can deliver more, better, and faster.
Absolutely. No, and I think there's a lot of excitement. I've been in the satellite industry for almost 25 years, and I would say there's a lot of excitement around players like Microsoft, really with such an active role in building ecosystems, really building this whole platform and ecosystem. So with that, I think we've reached the end of our time. Yves, thank you. This has been enlightening, and I could go on and on and on, but I will hopefully with you offline. But I want to thank you. It's been a pleasure. That'll end our session. And to those online, wish you the best and the rest of your PTC. So thank you very much.
Thank you. All the best. Thanks.
Thank you.